All right, 10-4, radical equations. So what we're going to actually do is we're going to start solving these. We're going to solve radical equations, and we're going to solve radical equations with extraneous solutions. Okay. Very first one that we're going to do, real world example number 1. So throwing us right into the deep water. Idris and Sebastian are sailing with a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. Find the length of the sailboat's waterline, round to the nearest foot. Okay, I really know nothing about sailing, and I see the red's not showing up very well. So this equation here, they give us, so H equals 1.34 square roots of L. H is the length of the hull, or the hull speed. Yep. And L is the length of the ship itself. So we have this right here. So we have 9 equals 1.34 square root of L. We want to solve for L. So we're going to take 9 divided by 1.34, and that is 6.72 square root of L. And then to get rid of the square root, what we're going to do is we're going to square both sides. Okay? So then we end up with 6.72 squared, which is going to be 45.16. So the ship itself is 45.16. They say round to the nearest foot, so we knock that off, and we say the length of the hull is approximately 45 feet. So the length of their boat is approximately 45 feet. Sounds like a pretty big sailboat to me. Okay, example number 2. They want us to solve the square root of a plus 5 plus 7 equals 12. So square root of a plus 5 plus 7 equals 12 is what we're looking for here. Right? So we want the square root be by itself. So we're going to subtract over the 7. So we have square root of a plus 5 equals 5. Then we're going to do is square both sides. So a plus 5 equals 25. And then we subtract over the 5 because we want a by itself now. A equals 20. So we subtract 5 from both sides. So a equals 20. So first we want to get the radical by itself, which we did by subtracting over 7. And then what we do is you square both sides. So then a plus 5 equals 25. And then we subtract over the 5. So a equals 20. And so that's just solving for them. Okay, what we're doing today is we are doing radical expressions. And with radical expressions, we're solving radical equations. And we're going to solve radical equations with extraneous solutions. Okay. So the first one that they give us is they give us a real world example. So Idris and Sebastian are sailing in a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. They find the length of the sailboat's waterline, round to the nearest foot. Okay, they have this equation right here. So as the hull speed, which we found is 9, is equal to 1.34 square root of L. L is the length of the ship. So divide both sides by 1.34. So 9 divided by 1.34 is 6.72 equals square root of L. Then what we want to do is to get rid of the square root, we want to square both sides. So 6.72 squared is 45.16. That's equal to the length. They say to the nearest foot, so we can knock off the decimal, and we can erase the equal and say 45 feet is approximately equal to the length of the boat. So it's a 45-foot boat. Pretty big boat. Okay. So that's example number 1. Example number 2, they want us to solve the square root of a plus 5 plus 7 equals 12. So that's the equation they want to solve. So what we need to do is we need to get the square root by itself. Like I said, treat the radicals as a variable. We'd always try to get the variable by itself and on one side. So we got this over here. So we're going to subtract over the 7. So square root of a plus 5 is equal to 5, because 12 minus 7 is going to be 5. So a plus 5 equals 5. Then we're going to square both sides. So a plus 5 equals 25. A equals 20 after we subtract the 5 over. So that's what a equals. So that's how we solve it. Get the radical, then square it, then solve. So that is example number 2. Example number 3. What happens when there's variables on both sides? Well, we've solved equations like that. We have the square root of k plus 1 equals k minus 1. Okay. So this is what we have right here. We want to solve for k. Well, we don't know what k is right here. So what we're going to do is just like we did before. We're going to square both sides. You got to remember this is quantity squared, not just k squared minus 1 squared. So we have k plus 1 equals k squared minus, this is going to be negative k, so negative 2k, and then plus 1. So I FOILed that all out. This is what I get. I combine my middle terms, subtract these over. So 0 equals k squared minus 3k. This is going to be minus 1, so that's just going to be a 0. So we're left with this. So 0, look at this, factor it. K times k minus 3. So we end up with the answers of 0 and 3. So we look at, say I have two things being multiplied together. How do I get a 0? We solved this before. This is a 0 or this is a 0. Or they're 0 at the same time. So the k is a 0, gives me the 0. I put in a 3 right there, that gives me a 0 there. The biggest thing though with square roots, we have to double check our answers. Okay? So if I put in 0 to my original problem looks like that. Put a 0 in here, I get the square root of 1. Good, I can't take a square root of a negative, so that's okay. So a square root of 1 is 1. But over here I got 0 minus 1 is going to be negative 1. So does 1 equal negative 1? So I cross out that solution. So 0 is not going to be, so this is what they're talking about, that extraneous solution. So I put in 3, 4, square root of 4 is 2. 2, so 2 equals 2. Boom. This is my only solution. Even though it spit out 2 solutions, 3 is the only solution that works. Okay? So that's why it's so important whenever we're working with square roots and stuff like that, we double check our answers. Some other times it's not as important, but this is one of those, whenever we're working with radical functions, we need to double check our answers because they will spit out stuff that does not work. Okay. If you have any questions, let me know.